Hi everyone. The goal of this video is to learn something about central and inscribed angles. I've given you a bank of some vocab you should already know. I'm just going to talk about the vocab you may not know. So look over these and make sure you know what a central angle is, an inscribed angle is, yada yada yada. Okay, the new vocab for today is intercepted arc. So an intercepted arc, and I'm going to give you just my definition, not necessarily the Webster definition, but an intercepted arc is an arc across from a central or inscribed angle in a circle. Okay, all intercepted arcs should share the same endpoints as angle, whatever angle you're talking about. In order to understand this, you need to know what a central angle and an inscribed angle is. So an example of a central angle is this angle right here. So angle AOB, I'll write that down, is a central angle, and its intercepted arc would be across from that angle. So the angle is really right here. Across from that is this arc here, AB, that arc here. And it should share the same endpoints as the angle. So the endpoints of the angle are AB, the arc is AB. So if you're talking an angle OB, that's a central, I'm just going to write this down just to recap that, central angle. Its intercepted arc would be AB. It's the arc that's created by the angle. Okay, you can also have an inscribed angle that works the same way. So let's say you have this inscribed angle here, and I'll call this C. So if we're talking about inscribed angle ACB, it's inscribed. Okay, it's not central because it's not in the center. It's inscribed because its vertex is on the edge, which those vocab words are right here. Okay, then its intercepted arc would also be AB because the endpoints, or where it opens up to, are AB. The endpoints are the same as the angle. Okay, the essential question for the video is what's the difference between arc length and arc measure? So arc length is what we already talked about. It's the distance, okay, of an arc. You would measure that in like centimeters, inches, miles, meters, something along those lines. It's how far or what distance you travel. That's like the crust of the pizza, from what we already talked about. So we'll recap. What's new for today, arc measure. So a measure is talking about the angle of the arc, which is measured in degrees. Okay, so it's how angled the arc is, or how far the slice of pizza, so like if it's a 20-degree slice pizza, it'll be a small slice. If it's a 60-degree pizza, it'll be a little bit bigger. If it's a 180-degree pizza, it'll be half the pizza, right? So that arc has a measure just like the angle has a measure. And it's kind of like how far it opens up, at what angle it opens up. Okay. On your own, when you're done with the video, you are going to do a review problem to find the length of AB. That you should already know how to do. What I'm going to teach you today is how to find the measure of different arcs. And we're going to start with a arc AB, which I'm going to draw right here. Okay, here's my arc AB. Now, all I know is I'm looking for a measure, which is in degrees. And I don't know the measure of AB, but I do know the measure of this angle here. So I'm going to call this point C. So I know the measure of angle ACB equals 75 degrees. But that's the angle, and now I want to find how I measure the degrees of the arc. Okay, that's different than the angle, but similar. Specifically, measure of ACB is 75. The arc that intercepts it is arc AB, because it has the same points as the angle. So if I want to find the measure of AB, I'd write the measure of AB with an arc symbol. So this is the measure of the angle, this is the measure of the arc. And this particular angle here is a central angle. So this is our first theorem for today, which before we write it down, I'm going to take a look at this interactive here. Okay, if you're looking at a central or inscribed angle, we can determine the measure of the arc that intercepts it. So for example, our central angle here is CAD. That's central because it's attached to the center. If the measure of CAD is 150 degrees, then the arc that intercepts it, which is arc CD, because it's got the same endpoints, is also 150 degrees. So the central angle is going to have the same measure as the arc that intercepts it. So I can change this and not be 150, and let's say our CAD is 79.6, that's this angle here. Then arc CD, that's like the arc across from the angle, is also 79.6. Here's one more example. If CAD, the angle, the central angle is 140, then the arc across from it is also 140. Versus, let's compare CBD to its intercepted arc. So CAD was the central angle, CBD is the inscribed angle because its vertex is on the circumference, not in the middle. But its intercepted arc is the same. So CBD opens up to CD because the endpoints of CBD are C and D. Now if I compare those two, are they the same? So the measure of CBD, or this angle here, is 70, but the measure of the arc CD is 140. So the inscribed angle is not the same as the arc. The inscribed angle is going to be half of the size of the arc. So if the arc is 140, the inscribed angle is 70. Or you can say that the arc is double the size of the inscribed angle. Different way of saying the same thing. And you can test this with a couple more angles. So let's say you've got an angle of about 30. So CBD is 15.2. So the arc is 30, the angle is 15, because an inscribed angle is half. Okay, now I'm going to write these things down in two different theorems here. So theorem 1 is about central angles. Theorem 1 here is about central angles and their arcs. Okay, and that theorem says the measure of a central, angle is the same as the measure of its intercepted arc. Oops, lost my pen. Or instead of saying intercepted arc, you can say the arc that's across from it. Okay, so if our central angle is 75 degrees, for example, the arc across from it, which is called the intercepted arc, would also be 75 degrees. So the angle and the arc are the same if we're talking about a central angle. Okay, versus what if we have an inscribed angle? So ABC here, this angle ABC, is an inscribed angle. What I want you to do first is find the measure of AC, which is the arc. Okay, or you can write this as the measure, not the angle, but the arc, measure of arc AC. Okay, the way to do that is there are 360 degrees in a circle. So if there are 150 and 110, we have a total of, let's add those up, we have a total of 260 degrees that are taken up in the circle already. So from here to here is 260 degrees. So if there are 360 total, how many degrees would there be left? So 360 total minus how many we have used up is going to give us 100 degrees left for that arc. So arc AC, whoa, scrolling out at the right time here. Arc AC from here to here would be 100 degrees. It's measure, not its length, it's measure. Okay, since I know the arc here, I can find the measure of the central angle that intercepts that, or also the inscribed angle, which the arc I have here is an inscribed angle because its vertex is on the center of, or not on the center, it's on the circumference of the circle. So if our arc is 100 degrees, then our inscribed angle is always going to be, referring back to this, remember if our arc was 30 degrees, our inscribed angle is 15. So the inscribed angle is half the size of its opposite arc. So if this is 100, our inscribed angle would be 50. So the measure of angle ABC is 50. And I'm going to justify this into a theorem, or maybe not justify, but summarize. So our second theorem for today is about inscribed angles and their arcs. And that theorem is an inscribed angle suppose I should have said the measure of an inscribed angle is half the measure, I'll add it there. That should be M, half the measure of its intercepted arc. An inscribed angle is half the measure of its intercepted arc. Or you can say its opposite arc. I like to say intercepted because that's proper vocabulary, and also it implies that the endpoints of the arc of the angle are the same. So if this is 100, this would be 50. If this was 200, this would be 100. Ooh, to go backwards, if this angle were 200, this arc would be 400. Or if this was 25, this would be 50, so on and so forth. So you can go backwards and forwards to find the given measures. Okay, so now that I've given you the theorems and the information, you should be able to find the measure, keyword being measure here, of arcs and central and inscribed angles. So that's all I have to say. If you have any questions, please ask them. Otherwise, let's go practice.